roller, tapos points na.
Yung roller yung nag-up.
Kapag roller kasi, bakit ko na hindi gilid to, di ba? Pero kapag roller siya, dalawa lang sa
Ano? Uy, bababa lang ako saglit. May meeting kami sa 2
ang voice lang nasa.
Ikaw nga.
Shoot kaya muna yung sa akin.
Roller is better.
Pag negative yung mga
Shell, next na ako, right? Matagal ba? Matagal ba?
Sa gitna lang
Assume that the force exerted by the roller is going to the
Wait lang. Join A. Join power downward. Join B. Power at point
joint.
at join D.
The force exerted by the roller is going to the left.
At join D, we assume that the force exerted by the
Palubat na ako.
At join D, we assume that the force exerted by the roller is going to the left.
Since wala nang nag-up before,
Yomar.
There's no more exerted
and a point C, you're gonna, ano,
Ay, gago, ito binura. Kaya ito ng boses niya.
We have two members intersecting at point B and at point A, point C. We have forces going downwards, it's 400 newtons and 500 newtons. And then the segment CB, there are two distances here, 1.5 meters each divided by 500 meters in the middle. We have a 2 meter height, 1.8 meters distance from point B, and 0.5 meters from the end of the segment. So what are we going to do? First, we're gonna draw the free body diagram of both members. So we're gonna draw it here.
basta yun.
Point C and point B.
Tingin natin siya.
We have the 500 Newton force going downwards over here, and the distance 1.5
The figure.
meters.
Hindi pa pala naman.
So, of course, we have to place forces that opposing 500 newtons going downward. We have Cy that goes up and Dy that goes up here. We have Dx going to the left, or to the right rather,
Wala na siya.
and Cx going to the left. With this, we're gonna use moment at point B to get the value of Cy. So you have moment at point B. You know that is 0. All the values of By and Bx will be equal to 0 since the moment passes through point B. We use the negative 500 newtons, negative because it's going downward, multiplied by 1.5 meters from point B, plus the value of Cy multiplied by 3 meters, all equal to 0. Simplifying, we have negative 750 meters plus 3 Cy equal to 0. We have to transpose the unknown to the other side to get negative 300 Cy or negative 3 Cy equal to negative 750 newtons. So we're gonna divide both sides by negative 3. We get the value of Cy as 250 newtons. So we're gonna, okay. So we have to remember that the value of Cy is equal to 250 newtons. Next, we're gonna get the value of Dy. We're going to get the value of Dy through using summation of forces along the y-axis, which is equal to 0, we're gonna use the same forces, but this time only those that are in the y-axis. So we still have 500 newtons going downward, plus the value of Cy, which is 250 newtons, the value of By, all equal to 0. Simplifying this, adding negative 500 with positive 250, we get negative 250 newtons equal to negative By. We transpose the By to the other side, so we get negative. So in short, we conclude that By is equal to 250 newtons too. As you can see from the given, both points have equal distances from the force that goes down, having 500 newtons. So we gotta remember that By is equal to 250 newtons too. Moving on, we have to know the values of Cx and Dx. We have to make use of the second free body diagram of this segment, which has point A and point B. Similarly, we have the forces of By going up and Bx going to the right. We have to oppose those forces at point A. We have an Ax going to the left and Ay going downwards. And we have to add the value of 400 newtons going down at that point. I'm gonna draw it here. Having a value of 400 newtons. So, we're going to use distances in the given. We have 0.5 meters here and 1.8 here. And the height is 2 meters. First, similarly to the process we've done at the first segment, we're going to get the moment at point A, which is equal to 0. So the forces acting at point A will be equal to 0 too. So adding the forces, make use of negative 400 newtons going downward, multiplied by the distance from point A, which we must add 1.8 meters plus 0.5 meters, which is equal to 2.3 meters. Plus the value of By, which is 250 newtons, over here, multiplied by the distance from point A, which is 1.8 meters. Since it's the y component. And then we're going to add the x component of B, multiplied by the y distance from point A, which is the 2 meters. All this equal to 0. Negative 400 multiplied by 2.3 meters is equal to negative 920 Newton meter plus 250 times 1.8 is equal to 450 plus 2px, all equal to 0. Simplifying, we transpose the unknown to the other side. Take 2px. 920 plus positive 450
Today we're gonna
is equal to
about methods of
235.
Ay, sorry.
Wait lang, cut mo nga. We need to get the x components of B and C because we now have Cy and By. To get that, we'll make use of the free diagram of this segment having these forces. We're gonna make use of the moment passing through A to get the value of Bx. So moment A is equal to 0. Since it passes through the point A, the values of Ax and Ay will be equal to 0. First, make use of the downward force, negative 400 newtons, multiplied by its distance from point A, 1.8 plus 0.5 is equal to 2.3. plus the value of By, which is 250 newtons, multiplied by its distance from point A, which is 1.8 meters, plus Bx, the unknown, multiplied by its y distance from point A, which is 2 meters. All of this equal to 0. Simplifying, we have 400 times 2.3 is equal to 920 Newton meters, negative, plus 450 Newton meters, plus 2bx. Simplifying more, negative 920 Newton meter plus 450 is equal to 470. Is equal to negative. Divide both sides by negative 2, we get 235 newtons. Use the value of Bx. Now we must remember that Bx is equal to 200. Pose. Wait lang. Now we have the value of Dx. We need the value of Cx. We can make use of the summation of forces along x-axis of this member. So, we have 0 is equal to Dx, which is going to the right, minus Cx, the forces is going to the left. Transposing, we get Bx is equal to Cx. Since we know that the value of Bx is 235, we now know that Cx is also equal to 235. Now we have the x and y components of B and C.
Steps will be getting the summation of the forces along y-axis and the x-axis. So first, we will get the summation of the forces along y-axis. So positive negative AY plus BY minus 400. 400 is the force acting downward here, and then point B. And then let's equate it to 0. And then after that, we will substitute the value. So negative AY plus the value of BY, which is the 250, minus the force 400. Then equate it again to 0. Then simplify negative AY minus 150 is equal to 0. And then put 150 on the other side to get the value of AY. So negative AY is equal to 150. And since AY is negative, let's make it positive. Then AY is equals to negative 150. And that is the value of AY.